In this video, I have explained interval of difference, backward difference operator del, and constructed a backward difference table. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world. Interval of difference. Let y is equal to f of x be any function. X takes the values a plus h, a plus 2h, a plus 3h, etc. and so on. Each difference by a constant quantity h, and it is called interval of difference. Let y is equal to f of x be any function. X takes the values a plus h, a plus 2h, a plus 3h, etc. and so on. Each difference by, it means the values of a is differencing by a constant quantity h, and that is called interval of difference. Then the corresponding values of y are f of a plus h, f of a plus 2h, f of a plus 3h, etc. and so on. F of a is for the corresponding value of y with respect to the value of x is equal to a, and f of a plus h is the corresponding value of y for the x is equal to a plus 2h, and similarly f of a plus 2h, f of a plus 3h are the corresponding values of y with respect to the values of x, a plus 2h and a plus 3h. Backward difference operator del. The forward difference operator is represented by the symbol delta, whereas a backward difference operator is represented by the symbol del, del. The backward difference operator del is defined by del f of x is equal to f of x minus f of x minus h, where h is called constant interval of difference. H is called constant interval of difference. Similarly, we can write del f of a is equal to f of a minus f of a minus h. Similarly, del f of a plus h is equal to f of a plus h minus f of a, because in place of f of a we need to write what? F of a plus h, and in place of f of a minus h we need to write f of a plus h minus h. H and minus h will be cancelled, therefore it will be f of a. Therefore del f of a plus h is equal to f of a plus h minus f of a. Then similarly del f of a plus 2h is equal to f of a plus 2h minus f of a plus h, because del f of a is equal to f of a minus f of a minus h. Here instead of a it is a plus 2h, therefore we can write f of a plus 2h minus f of a plus 2h minus h. 2h minus h will be h, therefore it is f of a plus h. Therefore we have written del f of a plus 2h is equal to f of a plus 2h minus f of a plus h, and we can write this one for any number of functions, so etc. and so on. It means we can use this backward difference operator for any of the polynomial functions. Backward difference table. What is a backward difference table? The difference can be represented in a form of a table, and that is called as a backward difference table. The difference can be represented in the form of a table, and that is called as a backward difference table. Now we shall construct the backward difference table. There is a general backward difference table. Now we shall construct the backward difference table. In a backward difference table, the first column will be values of x, the next will be values of y, the next will be first backward difference del, second backward difference del square, third backward difference del cube, fourth difference del to the power 4. So here I have not written backward, just I have written a difference. First difference, second difference, third difference, fourth difference. That is the first backward difference, second backward difference, third backward difference, and fourth backward difference. The next we need to write the values of x. The values of x, first one x naught. Then you need to write, you need to leave one line gap, and then you need to write the next value of x, that is x1. The next one line gap, you need to write the next value of x, that is x2. Then leave one line gap, write the next value of x as x3, etc. The last one will be xn. The next we need to write the values of y. These values of y we get by substituting the value of x in the given polynomial or a given function. Then we get the value of y corresponding to the value of x. The first value of y will be y naught, and the next you need to leave one line gap and you need to write the next value of y, and that is y1. The next one line gap, write the value of y. The next value is y2. The next value is y3, etc. The last one is yn. Then now you need to write the first difference. In case of a backward difference table, the first difference will be writing from the bottom of a table, and that one will be del yn is equal to yn minus 1, because del f of x is equal to f of x minus f of x minus h. So that is from the bottom of a table. Similarly, we can move towards the upward and we can write del y3 is equal to y3 minus y2, and right, it should be written in between the gaps of y2 and y3 rows and in the column of first difference. The next one, del y2 is equal to y2 minus y1. Observe the place where it has been written. The next value of a first difference, that is a del y1 is equal to del y1 is equal to del y1 minus y0. Del y1 is equal to y1 minus y0, and see the place where it has been written in the middle of x0 and in the middle of y0 and y1 in the row of first difference, and del y2 has been written in between y1 and y2 in the column of first difference, and del y3 has been written in the middle of y2 and y3 in the column of first difference. You need to write in the same way. The next second difference, del square. So again, coming from the bottom of a table, it will be del square yn is equal to del yn minus del yn minus 1. Then moving towards the upward, we'll be getting del square y3 is equal to del y3 minus del y2, and next value will be del square y2 is equal to del y2 minus del y1. Then there will be no again next second difference. This is the first one, whereas the first difference in and backward will be del y1, whereas the second difference will be del square y2. We'll be not getting del square y1, you won't get, right? The next third difference, coming again from the bottom of a table, del cube yn is equal to del cube yn minus del square yn minus 1. Del cube yn is equal to del square yn minus del square yn minus 1. And like that, moving towards the upward, the last term which we get on the top of the table will be del cube y3 is equal to del square y3 minus del square y2. The next, in the fourth difference, we get del to the power 4 yn is equal to del cube yn minus del cube yn minus 1. And moving towards the upward of an table, the last term which we get will be del to the power 4 y4 is equal to del cube y4 minus del cube y3. In this way, we need to construct the backward difference table and see and observe the places where the values has been written, and you will be understanding this one neatly when we solve the problems of constructing a backward difference table. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world.